Hello everyone and welcome back to the Frontier. How are we all enjoying Fanfest so far? Hooray! Very good. So, we're soon to be joined by CCP Wizard, who's going to run through physics and the Frontier. So, warm welcome please.
Thank you, Fanfest. So I am CCP Wizard, and I am a staff software engineer at CCP working in eFrontier. And I'm going to talk to you about physics of the frontier. So if any of you were in the panel called Real Physics, then this is the important physics of Eve. So I'm going to start with a summary, because there is a very nice talk by Becky, and I really want to get to it myself, so I'm going to try to keep it quick. The presentation is split sort of into two halves. The first half covers the changes or differences between the physics of New Eden and the frontier. I'm trying to lure it up, but I am a software programmer, so you're going to forgive me for screwing things up as I go along. The second half dwells into sort of a bit more gory details of the actual implementation in the Carbon engine. So a quick high-level overview about what we have changed. The first thing we did was to actually point the ship in the right direction, so the thrust in the frontier, rather than being in any direction whatsoever, it's always forward. So you can only move or accelerate your ship forwards, and you have to turn it before you can go any other way. We also enabled hiding, so there is occlusion. You can now stay behind a rock, and you will not. And if somebody comes in and doesn't peek behind the rock, that person will not see you. Of course, this is symmetric. You will not see that person either, but they're a way to hide stuff. Friendly fire is now in full effect, and bullets can no longer traverse through objects. So if there's something between you and your target, you're going to hit the thing that is between you rather than the target. We also added a bit more collision information to the ships, so they have a slightly better collisions. And we also upped the sub-step calculations in the calculations between the steps, so it should be more accurate now. And finally, you can no longer just place your module in your cargo hold for it to not have any mass. It will have the same mass whether you place it in your turret slot or in the cargo. So that's a nice bonus as well, and it will seriously affect small ships with large cargo holds. So, first things first, there are no pegs in the frontier, and if you don't know what a peg is, it's a perpetual energy generator, which is what powers New Eden. There's an excellent talk about this from Fanfest 2017, I think, which goes into all the details, but they're irrelevant for the physics of the frontier because they do not exist. So we still have faster than light travel, but instead of having the peg move us between these layers in the fabric of space-time, it uses negative energy to connect to the stillness, smoothing the quantum entanglement of the stillness to make a smooth ride, enabling the faster than light travel. Unfortunately, when the drives are not active, they are actually interlaced with the complex nature of the stillness, creating a drag, limiting the top speed of your otherwise nice vessel. And to power this warp drive, you need negative energy, and this is only possible with derivatives of crude matter, which is you use to fuel all the activity of your ship, including the warp and jumps. So, thrust is always straightforward. We actually have thrusters. The pegs in New Eden allow you to simply move your ship or accelerate the ship in any which direction you want. And the ships are modified such that for the capsuleers, it's always pointing in the direction of the velocity. In the frontier, the ship should always be pointing to where you want to accelerate your ship. So I have this in-shot footage here of a ship in orbit. You see this is the orbit point, this is the velocity, and the ship is turned slightly inwards so that you can actually accelerate it into the orbit you are traveling into. The orientation of the ship is not achieved by thrusters, but we have reaction wheels inside. This is to conserve energy, and is also safer than thrusters. Better stability, so you won't see any thrusters rotating your ship. It's all happening internally with these reaction wheels. And the reaction time of your ship is, of course, dependent on the moment of inertia, which is dependent on the mass. So the more mass you have in your ship, the slower it will react to your command as riders. The collision reactions are impacted. It's a bad pun, sorry. The pegs of New Eden create actually perfect collision spheres around the ships. So even if your ship is really long and narrow, your collision information or collision sphere is always this round that covers the entire ship. In Frontier, the ship's collision spheres are more compact, and we have several of them covering the entire ship. So collision should be more realistic. This is ChatGPT's version of this slide here. There will be no explosions when you collide. You will simply bump off, but in a slightly more realistic manner than was previously possible. Unfortunately, there are, if you activate your warp drive, there may be fluctuations in the quantum computations required to calculate the destination. And if you're unlucky, you may be able to warp into a structure, but otherwise you should not be able to fly through any of solid objects in the Frontier. The ship simply cannot do that without the PEG technology. And of course, you can also hide behind things. The PEG technology is excellent, but the PEGs give out this information field that other ships with a PEG can actually read. So no matter where you are in the system, the PEG will always give you a way through the local chat, except wormholes space is slightly different. In the Frontier, you actually need a clear line of sight before you can gather information about the pilot actually commanding the ship. And this enables stuff like if you go in and you want to mine in peace, you can go and just hide behind the rock you're mining so that when people come in and try to look for you, they cannot see you. Unfortunately, the drag that is caused by the warp and jump drives on the quantum stillness can be detected if you're close enough, so that if somebody gets a clear line of sight on you, they will be able to track you even if you try to hide then again behind the rock. So if you're spotted and you don't want to be killed, you probably want to warp away as quickly as possible. And turrets also work differently. In New Eden, PEGs allow the turrets or the missiles, or not the missiles, sorry, the bullets, the ammunition and the lasers to travel through objects directly to the target you're aiming at if it's within range. The Frontier turrets work slightly differently, and more similarly to what you would expect from regular turrets here on Earth, in that each turret has a sort of a cone with a probability distribution that the ammunition will travel into the cone, so more likely to the center, but there is some spread. So with this nice infographic, you can sort of see it. There is this ship here shooting at this one in the center, but because the cone is wide, the other two here are also possible targets of that bullet, depending on which random direction it flew into. There are some implications for this. So instead of just always pointing towards the center of the object, which should give you sort of the best chance to hit, if there is something in between you that is much smaller than your target, the turret tracking will try to aim away from the target in between to avoid you accidentally hitting someone you don't want to hit because it's not your target or your chosen target. But in some cases, it's just not possible, and in that case, you will simply hit the one that was in between. And this has actually caused me personal damage in one of the play tests. If you're in a large group, be careful. Now, this is sort of the lore-wise of it, but now I'm going to go into a bit more detail about why we're using all of this lore to hide away from the fact that we're not an astrophysics simulation at all. This is what drives the physics of the spaceships in both EVE Online and EVE Frontier is the Destiny physics engine, which was designed in a way to be completely deterministic. So we can, with a given initial condition, calculate the position of any objects in the physics engine for an arbitrary amount of time. So we can pick whatever times. We still do time stepping for collision reasons and obvious synchronization issues. But in principle, in theory behind it, we could do basically no matter how long the time step is. So the model we use is actually a Newtonian fluid at very low Reynolds number without gravity. So we're astrophysics simulations without gravity, the only one in the world. It is, I said this already. The other thing is that it enables, it gives a maximum velocity to ships for given thrust. So this gives us slow speeds so that you can actually, stay on grid within a few hundred kilometers and control your ship reasonably well, allowing for these epic dogfight battles that we do have. So if we were realistic, your ship would be whizzing past at almost light speed and you wouldn't be able to do anything because it would take you half an hour to stop. So this gives us sort of a better aspect to actually have a fun game. The orientation that we've added to the physics engine is actually done in the same way. It's used the exact same equations as for the linear motion, except that it's just done for rotation. And it is accurate for the linear motion, but for the rotation, I actually had to cheat just a bit. I have a PhD in astrophysics, and I used to work in academia for a long time. This was one of my first tasks at CCP, was adding this orientation and having to cheat and not solve the differential equation accurately was sort of a mind-blowing experience. It was super cool to be able, I cannot solve this, I need numerical solvers. But if I make this one simple assumption, and the assumption is that your angular momentum and torque have to align for it to be accurate. If they don't align, it still works. It's just not solving the same equations. But it gives me a closed source form, so I can actually solve this for arbitrary time steps as well. The issue with that is the original model, if you said, I want to go to that point, then it could calculate accurately how you should accelerate to get to that point in the quickest manner possible. Now that I don't have the acceleration going any direction whatsoever, I have to do some iteration and some approximations. So I first have to, given your position and velocity, I find in what acceleration I need to get you to the point as quickly as possible. And then I say, how quickly do I have to rotate to get to that orientation so that you can get the acceleration in the right way? And apply that, and then I apply the acceleration in the direction of the position you're currently in and redo in the next tick. So this leads to, in some cases, some bizarre movement. So especially if you try to approach an object that is very close, but you're not oriented the right way, you will take a circle around it rather than waiting to turn first and then accelerate. So you can have fun with it. It creates some nice screenshots or clips with it. Now, for the line of sight calculation, we utilized the very nice octree grid. If you don't know what an octree grid is, it simply, we split the space up into cubes, and each cube is then split up into smaller cubes, and they're all connected, so there's a nested set of cubes. Of course, not absolute cubes, they're just space in memory on a computer. And this was used for fast lookup for collision calculations, and it's still used for that. And what we did was we extended it to actually also be fast lookup for line of sight occlusion. So we can ray trace through the octree grid and find out if there is something between us and another point. This sped up the line of sight calculation by a significant amount, I think 2 orders of magnitude, which enabled us to do this fancy line of sight code. Unfortunately, we have a slight issue with the occlusion calculations, because if you want to hide stuff, you have to know at each step if there is something between you and the other player. So we actually do this for player ships and any other object on the grid that can fly. And this is basically the amount of time scales with the multiple of the number of things that can move and the number of players on the grid. So this easily eats up more than 90% of all the calculations the physics engine is doing just to calculate to see if you're hidden behind a rock. So we are working on ways to make this more efficient, so you can have big fleet fights in the frontier as well as in New Eden. The collision implemented details is that instead of just being a single sphere, we use spheres because spheres are super easy to calculate for collisions. We now allow for the ship to actually have multiple spheres. So if you have a narrow ship, the collision information will be made of maybe 10 spheres aligned along the ship, or more complex shape. So it's not perfect, but it does have a huge impact on the way, and especially because the physics engine handles the occlusion calculations. And if you have a long and narrow ship and you have a sphere that covers the length of the ship, it's going to cover a lot of empty space around the ship as well. So you could be hidden behind that large ship and then pop up maybe the length of the ship above the ship, which is very weird. So we wanted the physics engine to have better collision information for the ships. This has the addition, as we now have more realistic directions you're pointing in. So if you hit someone directly at the center, you won't be able to bump them. So what will happen, because you're basically hitting them at the center of mass, they will just bump sideways. They will not orient them. They will have a velocity that's going slightly sideways, but they will not rotate sideways. You have to hit them from the front. And if you do, especially if you have a large ship, massive ship, and the other one is in a slightly less massive ship, you can actually get them spinning. It's quite comical. The first implementation, I did not put any limits on the maximum angular velocity the ship could have after collision, and I collided with something, and then my ship just kept spinning for minutes. We fixed that. And the chance to hit calculation now also, it also uses the collision information of the ship. And we have this cone which is authored on the turret, but we also account for tracking. So if you're moving in angular motion relative to, so if the target is moving with high angular motion relative to yourself, and it's not just transversal, so if you're orbiting someone that's stuck here, you always face it the same way, so the relative angular momentum of the target to you, the orbiter, is 0, whereas your angular momentum, because you're running in circles around the target, is very large. So it's not symmetric like we have in the old physics model. And what happens to model this sort of, think of it as you're trying to shoot a duck with a shotgun and the duck is moving very quickly, so your aim is going to be a bit off. So it's modeled in a way that the cone actually increases in size. And we also use the octree to speed up the calculations of this cone, so we can easily ray trace everything that's within the cone. If you ever play Frontier, we still haven't quite updated the UI with the information required for this. So we still give you information about optimal range and fall-off range. That is not absolutely true, because the actual optimal range depends on the what's it called? The size of the ship as observed by you, so the angular size of the ship. So if you have a battleship which is huge, and then you have a frigate right next to it, they're both still and everything else, you're going to have a lot easier time hitting the battleship, as sort of is obvious. It's easier to hit a large target than it is to hit a small target. So this is the end. I'm just going to leave you here with this summary, and I am open for a question, delivered in 20 minutes.
Do we have any questions in the audience? Yeah, over there.
Does occlusion only applies to turrets, or some other modules like warp disruption, web fires and stuff like this?
At the moment, it's only turrets. So mining lasers, they can cut through anything to the target. Webifiers, warp scramblers, they work with low frequency radio waves, so they travel around things.
Hi, will damage to ships, collisions with ammunition affect propulsion at all?
No. At the moment, no. It could do so in the future, but that is really not up for me, the software engineer, to decide.
So projectiles, no, the turrets don't have an optimal range. So would a bullet fired from a ship conceivably hit a target far, far, far beyond the intended target, say 100 kilometers away?
Yes. And there is no flight time, so it's instantaneous. So theoretically, you could hit a target that is on grid with you 3,000 kilometers away, but you'd have to be extremely lucky to do so. But the fall off with the new system is much longer than what you're used to from EM-Online.
Do bullets, when they're fired, or the munitions, do they kind of drop lower, like in the Terror world?
Why would they? There is no gravity.
Of course.
In a real-world scenario, bullets from a gun could travel infinitely long distance in space in real physics. Is there is the fire from a ship in Frontier tied to a ship on a target, so the bullets will eventually just vanish if they don't hit anything?
Yeah, like I said before, you don't hit ships that are not on grid with you. So if you fired to the direction of a planet and you knew that there was someone there, but you couldn't see them because they were off grid, then you wouldn't be able to hit them. But if they are on grid behind something, and then there is a possibility, yes.
So with the new mass system, does a higher mass result in a slower rotational velocity as well?
Not the peak velocity, but the rotational acceleration. So the peak velocity, both in linear motion and orientation, depends only on the mass. No, sorry, only on the friction, which is, we call it the agility parameter, agility is actually 1 over friction. It's complicated. But mass changes the time scale. So as you increase the mass of your ship, everything else stays constant. It takes longer to accelerate to the full speed.
Awesome, thank you.
If a ship consists of multiple spheres, would it be possible to make them basically hit zones? So for example, if there's a sphere at the back of the ship where the engines are, would it be possible to make this spot then increase the damage potential to a propulsion module, for example?
That is definitely possible sometimes in the future. It will depend on what game design wants. But it also creates issues in the sense that we use the same targeting system as EVE Online, so you target a single ship. You would probably want to target the propulsion system of that ship. So how do we allow that? So it's a UX issue as well. So there's a lot of things that we need to modify before we could go that. The physics engine could handle it, but everything else is a different matter.
I haven't played EVE Frontier, but is there like a high sec in EVE Frontier? I mean, I'm asking in the context of friendly fire. I mean, if you fire a turret in high sec, unpleasant things happen. So, or may happen. So
yeah. So Concord has not been imported to the Frontier, so there is no concept of security.
not yet. Okay.
Well, not yet. I don't know. You'd have to ask someone else than me. I cannot answer that.
Any other questions?
So presumably if modules in the cargo hold effective mass, offlining modules won't make your ship accelerate or align faster?
Depends on the onlining effect. So there are ways that modules could be heavier fitted to your ship than off your ship in the game engine. Right. Okay. Currently, we don't have any modules that work that way, but we have a very flexible attribute engine that can do stuff unexpected.
With the new physics implementation, is there any effect from either jettisoning or shooting your own weapons on your acceleration? Right.
No, there is no conservation of momentum with shooting or jettisoning. No. You will accelerate faster if you jettison all the extra mass, but that's it.
Just curious, how heavy modules are relative to the ship mass?
Depends on the module and the ship. The ones we have now running in our alpha testing, they're not that, it's not a huge effect. So it's mostly on the smaller ship, if I remember correctly. So your starting ship, fully loaded, fully fitted with all the cargo extenders, full of heavy ore, is about 50% heavier than the base mass, if I remember correctly. One over there, right in the back.
Since this is the same engine as EVE Online, is there any chance we will see updates to EVE Online from what we see here?
possible. I'm not on that project. I cannot answer it definitely, but they will have access to it as this is our in-house game engine. And if they make that decision, they could theoretically put it in, but I don't think there are any plans because some of these are very disruptive to the gameplay, so it would make a lot of people very angry, I guess. Okay, if there are no more questions, I encourage you to go to talk or see the talk by the actual physicist we flew in for the Fanfest. Thank you for the nice questions and being my audience.
CCP Wizard, everyone. Well, that's it. That concludes today for Frontier, but we'll be back tomorrow with a really engaging schedule, so hopefully see you all then.